This conference will now be recorded.
Okay, so here, right, at least any idea about DevOps, Revati?
Yeah, Ram, because that interview I told, no, 2 months before I prepared, DevOps is kind of development and the operations. So it's kind of correct.
Yes, yes.
Yeah. So what is my understanding is like, so once the developer writes the scripts, everything, so they all different types of developer, they write the scripts and put it in the repository. So
Okay, fine, that's fine.
yeah.
That's fine. Okay, so here, right, so DevOps means actually Dev plus operations, like development plus operations. In DevOps, right, so we have so many modules and so many like tools itself.
Okay.
Now, for example, I am from the just to assume that I am from the Java background, some development background. What I can do, I will do Java development. So plus some little bit operations also, like deploying some little bit operations.
Okay.
For example, assume that I am from the Linux or some infra admin, okay, infra admin background. So then, okay, so then mostly I will work on operations. So okay, some little bit development using shell script or Python or Ansible or Terraform something. So okay, yeah, like developing shell scripts and developing Ansible scripts, developing Terraform scripts or some Python scripts to automate infrastructure. So I will not work here and develop any application. These guys, Java guys or Java guy, .NET guys, so they will work on the developing their applications. It's a Java applications or .NET applications, something and all. Okay. So here, right, I will not work on the so to develop applications. I will work on the automate infrastructure side using shell script, using Python script, or using Terraform, or using Ansible or Puppet, or so some tools. There's operations like
Okay.
maintaining, administrating, so like kind of operations. That depends upon the background. Okay, so from where we came. Yeah, right. Anyway, you both are from the like kind of not from development background, right? So most probably, so you will get tomorrow a project something like that, like from this side. You will not get project from this side, okay? Like development side. So you will get like infrastructure, or something like DevOps.
Okay.
So here, if you want to discuss about tools, so we have a lot of tools. Ansible. Any idea about Ansible? Any idea about Ansible?
No.
My team use it. They do Ansible.
Ansible work, right? Okay, right.
They do Ansible.
Okay.
So we deploy it.
Okay, we'll discuss.
To develop it, that part I'm not sure.
Okay, no problem. It's very easy only. We'll discuss. Ansible, Git or a GitHub. So we can use Tomcat. We can use Jenkins, Docker. Here we can use SonarQube. We can use Nexus. So okay. In our course and our class, we will discuss in these tools: Ansible, Git, GitHub, Tomcat, Jenkins, SonarQube, Nexus, Docker. And anyway, we will cover some Linux part, some UWS part also we will cover.
Okay.
So Ansible, right? Using Ansible, so we can provision or we can create the infrastructure. Means Linux servers, Windows servers, all these we can create. Like infrastructure, the servers, networking, whatever we need, the DNS word, all those we can create, and also we can configure the server part also. One like installing servers, tools, software in the server. For example, I have 100 server. So in 100 servers, I want to install some five softwares. Can you put in mute? For example, I have the, so 100, will take 1000 server. I have 1000 server. In 1000 servers, I want to do some tasks. For example, installing some 5 packages or 10 packages or at least one package. If you want to do manually read in 1000 servers, it will take at least 1 week or 1 month also. We don't know. Same thing if you use any Ansible, any Terraform like Puppet and all. So with one script or maybe within half an hour or 1 hour, so we can install the whatever tools or whatever packages we required at a time. In 1000 servers at a time, I can install it. So here we can save the, so lot of time and resource also we can save it. So Ansible we can call server configuration management or manager. So like SCM, server configuration manager. So using Ansible, we can provision or we can create the infrastructure. Infrastructure means server, Windows servers, Linux servers, databases, networking, DNS, all this stuff and all. Okay. So and also we can configure the servers. Okay, within the servers we can install whatever packages we required. Okay. So Tomcat, Java, testing, so many tools, so many packages, whatever you want. So we can install at a time in multiple servers, 1000 servers, 1 lakh servers also we can install. Okay, any questions here so far? Gaurav or Revati?
No, Ram.
So in deep we'll discuss just here. I'm trying to introduce the tools only. Okay, so the architecture, that flow, all those things we will discuss later.
Okay.
So here we can use Ansible or Terraform. We have, or we can use Puppet. We can use Chef. So there, okay, these are all the competitors for Ansible: Terraform, Puppet, Chef. So nowadays mostly people will go for Ansible or Terraform. Ansible or Terraform. So if you know Ansible, automatically you can learn the Terraform or Puppet, whatever. So it's like similar tools. So any idea about a Git or a GitHub or SVN? Gaurav, are you there? Gaurav, are you able to hear me?
Hello.
Okay, Gaurav. I can hear. So any idea about a Git or a GitHub?
Yeah, Ram.
Okay. Revati, any idea about a Git or a GitHub?
So all the developers write the script and repository in a place that is called GitHub. That place, is that correct, Ram?
Yeah, exactly. So we can call repository
Okay.
or versioning control also. Versioning, say whatever you told is correct only. So developers, not only developers, anyone can use it. Developers, admin, system admins, okay, DevOps guys, whatever they write, the coding programs or scripting or okay, whatever they want, so they can push into GitHub. Okay, so they can save it, and they can mention the versioning control. So in detail, we'll discuss later. Here we can use SVN also. That okay, both are SVN on the GitHub, or GitLab. These are the competitors. Any idea about Tomcat? Tomcat.
Tomcat is kind of application, right? I mean, Java-based application, right?
So application server. So we can deploy the application in Tomcat.
Okay.
For example, if you take anything, Google, Amazon, Flipkart, any XYZ, okay, websites, maybe they want to deploy into some way, maybe Tomcat as application server or web server somewhere. Right? So all applications we can deploy into Tomcat. That we'll discuss. I think Jenkins you both knows. I think so. It's a CI/CD tool. Okay. Continuous integration and the continuous deployment.
Content development, yeah.
So that we will discuss later. So okay, some people can use Jenkins, or we have Bamboo also. Depends on the projects, depends on the companies. Some companies will use Jenkins, some companies will use Bamboo. but most companies or most projects, 95%, so will use the Jenkins only. SonarQube, any idea? What is SonarQube?
No, Ram.
No.
Code quality. So we can check using SonarQube. So we can check the code quality. It means how many layers are there, how many bugs are there, any defects, any smells. So those things are done. Okay, developers, so they can check the code quality in SonarQube. So based on that, they can improve the coding skills. That's the coding in the application. So in any duplicate functions, any duplicate classes, or any smells, any depths, any bugs. So those things are not, so they can monitor the SonarQube. So based upon that SonarQube feedback, so they can improve the coding, the code in the application. So Nexus, any idea?
No, Ram.
Okay. You see Git or GitHub, GitLab, it is like code, something code. You can say code repository. Code repository in Git or GitHub, so we can save coding scripting only. Java scripting, okay, Java code, Python, shell script, whatever code and scripts all we can save into GitHub. So here, right, Nexus is also one of the repository, but here you can save the artifacts, only artifacts. Any idea about artifacts? Any idea about artifacts?
Not sure. So in
Okay.
what?
Any idea about where jar files? Have heard about jar files, where files, this thing?
So once we start the Jenkins, we can use this jar.war, right? In the,
Yes. Yeah. You're right. Yeah.
So how
You can,
different is it? I mean, see, in Nexus, you say it's a repository for artifact, right?
okay.
You're keeping it jar file or EAR file. So same way, those
Okay.
files you can keep it in Git also, right? Git is not only for version control. You can keep it in jar also, right?
Yeah. If you want, you can store it. You can store it. But the best practice, so people will go for the artifact repository. So here we can maintain. So here in Nexus artifact repository, so we can maintain the life cycle also. For example, so like 1 month old artifacts or 1 week old artifacts, I can remove automatically, or I can like something like so. And also we can use the artifact promotion. For example, so today I have multiple like different environments, dev, test, production, day or something. Today I will deploy my artifact into dev, for testing purpose, like development environment. Once it is successful, so then I can promote same artifact into some other be production. So like that also we have some options in the Nexus compared than GitHub. Okay, Gaurav?
I guess so. Whatever you're saying about Nexus, if I correlate with my work, I think you're talking about Stash.
Stash.
Something related to Stash, right?
Yeah, Nexus, Stash, or JFrog, these are all similar tools. So you can use Nexus, Stash, JFrog, or Cloud S3. Or some okay. There are so many tools. Okay, it's all similar tools. Okay, Gaurav.
Yeah, got it. So we use a Stash actually to keep those codes.
Okay.
And then
If you know, if you know Nexus, right, that is very easy to learn Stash or JFrog, any other repository also. These are the similar tools.
okay.
Okay. So here that I have the Java code. So, okay. So using Maven and Gradle. Maven and Gradle, right? So we can if it are in general language, we can convert the code into artifacts. Artifacts means jar files, okay, var files, ER files, something. Okay, so for example, I have some Java code or any other .NET, some coding, some programming language, right? So that coding we can convert into artifacts using Maven and other. These things we will call build tools. Maven and this is the build tools. Using build tools, so we can create the artifacts from the coding and that. So these artifacts we can save into Access. Okay.
Okay.
Okay. Just here simple. Okay. I'm trying to introduce the tools only. But last week I will tell you that other architecture. So Docker, any idea?
Docker, not much. I mean, we don't use it. We don't use it actively.
It is like container based servers or infra. You can create infra servers, okay, or deployments, whatever we can. So we can use it. So Docker. Here we can create the containers. So container means like kind of VMware. We take VMware and in a idea about a VMware.
VMware.
Yes. Any idea?
Yeah. Is like your virtual machines, right?
Yes. But basic, how it will work?
Yeah, I mean, I know the basic. I've used it long back.
Okay, simple. Here at VMware at PC, in one hardware, we can create the multiple servers, right?
Correct.
Okay. VM1, VM2, VM3, VM4, like in one hardware, so we can create the multiple VMs like VM1, VM2, VM3. Same thing here also, Docker also in one server, in one Docker server, we can create the multiple containers. Container means nothing but one server. So Docker is OS level authorization. Okay, so means in one OS, in one server, I can create the multiple containers. It's container nothing but it will work as one VM. Okay, so in deep, so going forward we'll discuss. Okay, so that architecture, all those stuff under. Okay, so these tools. Okay, so these tools we are going to discuss. Yeah, tell me, Gaurav.
It is nothing but your virtualization of service. So let's say I have a service running in my Linux machine. Or
Exactly, just virtualization. Exactly, yeah, exactly.
If I'm getting more than certain limit of request and one of the container or one pod, whatever it is not able to handle, and we know we are getting some kind of timeout or request failure, so we can spin up a new.
Yes, exactly. Yeah, exactly. Yeah.
Got it.
Yeah. So these tools we will use in our class or our course. Ansible, so GitHub, GitLab. All the three are similar, and SV has been also similar. If you know the GitHub or GitLab, okay, so it's very easy to work on SVN also. Tomcat, so Tomcat 8 we will use Jenkins, SonarQube. We'll use Maven in our class. And Nexus we'll use, Docker we'll use, and we'll create our servers on the AWS. So okay, in AWS, so we will use the Linux servers in AWS. AWS is free account. Okay, you can create your free account and you can use 1 year that AWS account with some limitations. We don't want to pay also, so it's zero payment. In AWS, so we'll create the Linux servers. Most probably, okay, so 95% is all the companies, all DevOps project will run on the Linux servers. Linux means Red Hat Linux, Oracle Linux, Ubuntu, okay, Fedora. Okay, so here at least you should know how to work on the Linux servers. Anyway, I will provide commands and okay, so in daily basis we'll work on the Linux server only. Whenever I'm running any one command, I will try to explain that command. It's very easy, okay, so you don't need to worry about. So here we will create our Linux servers in the AWS account. It's free. Okay, you don't need to pay none. 1 year you can use that your AWS account with some limitations. Okay, right. So any questions so far?
No, Ram.
No, Ram, so far good.
Okay, right. Okay. So do you know that AWS, and DevOps, the life cycle, the architecture, how it will work?
No.
Okay. So, okay, can we continue the architecture or life cycle? Any
Yeah.
questions? Okay. So, okay, here I have my developer one, maybe developer two. Okay. I have one project. Take any budget project. Next project, I have some developers. Dev one, Dev two, not only developers. We will have the testers, manual testers, or automation testers, or performance testers, ETL testers, database testers. There are so many testing also. That depends upon team. They'll use the any type of the testing tools and all. Okay, so here I have a developer one, developer two. So I have my repository, source code repository. So here we will use the Git, GitHub or GitLab. The commands, same commands. Git, GitHub, GitLab, same commands, exactly same. Okay, so I have some GitHub or GitLab, some source code repository. This thing will call a source code repository. Nexus is the artifact repository. That value files, you can also save into Git or GitHub. But for best practice, okay, people will use the for different purpose. So Git or GitHub, GitLab is source code or SVN. Is a source code repository. Nexus, JFrog, Stas, these things are the artifact repositories. Yeah, repository means simple storage. That's it. Like SharePoint. Storage, some storage. Okay, repository means this kind of storage. Okay, so I have GitHub, GitLab. Like I'm using like GitHub, GitLab as a source code repository. So what these guys will do, for example, today, so developer one or developer two, whatever it may be, okay, he will write some 100 lines or 10 lines. Okay, what he will do now in first hour or second hour, he will write 10 lines code and he will push this code into GitHub. Here I have the one branch. Technically we'll call the branch in GitHub or SVN. Branch means nothing but this kind of folder. So here I have one folder called branch. Technically we will call a branch. We will not call folder in GitHub. Okay, just try to remember this technical keyword and all. This thing I will call a branch. All these things I will show you. Okay, practically I will show you. We will configure that. Okay, 100% lab. Okay, so we can configure into our laptop. I will help you. Okay, so there's no theoretical. It's 100% is okay. So we can practice the DevOps. All the tools we can install. All the tools open source. We don't need to pay single rupee also. These are all open source. All tools we can download into our lab. We can set up. We can integrate. We can use it. So I will show you later. Just here I'm trying to explain that life cycle, workflow, or architecture. Okay, so here I have one branch called something. Just some name it. For example, so dev one is working on the one module. Take some module one. Okay, module one. Same thing, developer two also. He is working on the module two. Module two. Here, right? If you see like the traditional, okay. So if you want to test your application, okay, if you want to test your application, so the developers should complete all the developing work. For example, right, so all the modules, so they should complete all the modules, all the coding, then only you can test it, right, Gaurav?
Yeah.
Okay, so here not like that. For example, developer one just writes 10 lines. The 10 lines you can test it, or 20 lines you can test it, or end of the day. Okay, so you can test it. So you no need to wait for that full complete code and all. Okay, so today, so developer one or developer two. Okay, so you write the 10 lines code, and okay, you'll push this code into the branches. The branches is the branches. Okay, so in the GitHub, right, we'll have some branches, a kind of folders. Take your laptop. In your laptop, right, you can create the multiple folders, movies, resumes, some folder one, folder two, like that. Here also same thing. Okay, we can create the branches in GitHub. So developer one is working on the module one, developer two is working on the module two, and so developer one or developer two, so you write some piece of code, maybe 100 lines, 1,000 lines, or some 10 lines. Okay, you can push whenever you want in a day, you can push several times into GitHub. So developer one, some developers. A developer one means not a developers. Any coding, any scripting, some coding, some programming. Okay, some programs. That Python, Java, Node.js. There are so many programming languages. Shell script also script. Any script. Okay. So this guy writes some piece of code, 10 lines, 20 lines, and 100 lines, and he can push his changes to GitHub in several times in a day. So this thing we will call the continuous integration. Continuous integration means simple. So the developers, they can push or they can commit their coding or their changes into source code repository, so several times in a day. So this thing we will call the continuous integration. Tomorrow, if someone asks in the interview what is the continuous integration means, the developers, they can push or they can commit their code into source code repository several times in a day. I will show you that one. Continuous. So just you can indeed continuous integration is a development practice where developers integrate. Integrate means simple. They can push, they can upload. In general language, what we'll call in uploading or pushing code. But the technically we'll call integrate. Developers integrate code into a shared repository. Shared repository means the source code repository. GitHub, GitLab, SVN, whatever it may be. Repository frequently, preferably several times in a day. Okay. So here also you can see. If you want, you can read, or if you can save this thing, this keywords and all. So later you can search, you can just do whatever you want. Okay. So any questions here? Continuous integration.
No, no.
Revati? Okay.
So what you're saying is each of the developer is writing a code, let's say 10 lines of code or 20 lines of code, and he's just pushing it into his local branch. He's not still he has not merged it to master branch. That's what you're saying, right?
Yeah, yes, exactly. Okay. That master branch that we'll discuss. Okay, that's very advanced. Okay, Gaurav.
Yeah, sure.
Yeah, is integrating his code into his local branch only. Yes.
Okay.
Okay, right. So this thing we will call the continuous integration. It's very important. Okay, so in interviews, to test your basics, so they will ask what is continuous integration. Continuous integration means nothing. So the developers, they will code some piece of code, maybe 10 lines or 20 lines, 100 lines, okay, something. So they can push or they can integrate, they can commit their code into your is local repository, a local branch in the repository, SVN or Bamboo, not Bamboo, GitHub, several times in a day. So then next phase, we have the Jenkins. Jenkins is the CI CD tool, continuous integration, continuous deployment, development, whatever. So I have the Jenkins. I have the Jenkins. Okay. Just leave this part. That okay. That GitHub just for 5 minutes. Just leave it. Just space. I have the Jenkins, Bamboo, whatever. Okay. Most 95%, so people will use projects will use Jenkins only nowadays. Okay. So what I will do here, I will download some plugins or some softwares, and I will integrate those plugins or their softwares into Jenkins. For example, some JUnit. Got any idea about JUnit?
It's a Java-based framework, right? So that
Okay.
we use it for testing, right? Unit testing or something.
Yes. For unit testing and all. Unit testing means just any idea about unit testing, Gaurav?
Yeah, I mean, so whatever developer has written a code, right? So he can do his unit testing and then just like right?
Yeah.
He can
Okay.
just, test his code, whatever he has written, whether it is doing the intended function or not.
Okay. This is simple code. Okay. Just testing the simple code whether this code is working or not. So here we can download some plugins. The plugins means like kind of softwares. For example, JUnit I will download. Then I will download Maven. Maven. Already we know what is the Maven. Just we discuss it a little bit. So going forward, we will discuss in depth. Okay. So what I will do, I will download Maven, and I will download SonarCube also. SonarCube, and I will download Nexus. Nexus. Already we know what is the Nexus, and already we know what is the SonarCube. What's the Maven also we know. JUnit means kind of testing tool, just kind of testing plugin. So using JUnit, we can test the basic testing. We can do it. Okay. So what I will do here, all these tools I will download, and I will integrate with Jenkins tool. Okay. And also I will integrate my GitHub with Jenkins. So here I downloaded and I configured my GitHub, JUnit, Maven, SonarCube, Access, and I integrate with Jenkins. So here I have developer one. He will write his code and I will push into wherever some branch. If you test, you can test. So here we integrated our GitHub with Jenkins. So if you want manually also you can run the job, you can trigger the job, or also we can automate. And using JUnit, using JUnit something, you can test. Then using Maven, we can build that artifact, means like jar file, var file. Using Maven, we can build a Java code into jar file, var file, or the ER file. So before building, right? Before building, so we can use the SonarCube also. SonarCube before building. Before building, so what we'll do, we can use the SonarCube, and we can test the code quality. How many classes are there? How many functions are there? Is any duplicate class, any duplicate function, any spells, any depths, any bugs? All these things and all we can we can get using SonarCube. First JUnit, the simple testing. Once done, automatically the job will go to the SonarCube. Okay, here it will display. Okay, boss, this many duplicates lines are there. This many duplicate functions are there. This many depths are there. This many smells are there. Just it will display some report. Just 1 second. Here. Okay, so what here, right? First, I will test JUnit. Okay, JUnit. Simple testing whether the code is working or not. Then I'll go to the SonarCube. The SonarCube, here also we have to configure. I will tell you how to configure all those things. And we have to configure. So what to text or what to display. Okay, what to scan. automatically, depends upon our configurations. It will scan the code. It will check any duplicate lines, duplicate functions, duplicate like classes, any smells, all those things. And all. It will give one report. It will give one report. So based upon this report, okay, developers they will improve their code. For example, so here I'm testing red using JUnit. Right? For example, so here you find some bugs or some defects. Okay. So again, what they will do? So they'll fix the bugs, whatever the errors, the bugs, okay, the defects. They'll fix. Again, they'll push their code into GitHub. Again, they will test using the basic test JUnit. So then they'll go for SonarQube. SonarQube also will display some list of some feedback as we discussed earlier. So if necessary, again what they will do? Again they'll fix the code. They fix the code. They'll improve the code quality. All those things. They'll push code into GitHub. Again JUnit. When done successfully, then they'll go for the SonarQube. If everything is fine in SonarQube, then so we can go for the Maven. Using Maven, I can build the code into artifacts like jar files, var files, something and all. Okay. Once I build my artifacts, I can upload those artifacts Nexus repository. Nexus is the artifact repository. So I can upload this kind of storage. Okay. So I can upload or I can save my artifacts into Nexus. Okay. Any questions here so far? Revati, Gaurav?
So this part also comes into continuous integration, right?
Right.
Yeah. I will tell you, Gaurav. Just I will tell that one. I will tell you.
Okay.
I'll tell you. Okay. So any questions, Revati, so far?
No, Ram.
Okay.
1 minute.
Sorry, Revati.
I have a doubt. So what? For the JUnit test, if we find any defects in that, coding, once it's sent back to the developer write the code and send again they write the code again. They send it to the GitHub, right?
Yes.
Repository.
Yes.
So once the JUnit is fully tested, then only it go for the SonarQube.
Yes. Exactly.
Okay. After that, Maven.
Yes.
Okay. Yeah.
Here I have servers. This is, for example, this is dev server. Okay. So dev server. This is like a QA or UAT, some server, okay. So finally, I have the production server. Okay. So in Nexus or in JFrog, whatever in artifact repository, I have my artifactory. So for example, first what I will do, I will download this into dev server. Some lower environment. That depends upon the company. So they will use the naming convention. Dev, QA, UT1 or lower environment, a testing server, something. Okay. So I will download it to test server. From all this automation. Okay. So we no need to do a manual and all. So we can configure all these pipelines. I will tell you. So I will download into my test server, a test environment. So my testers or automation testers or performance testers or manual testers, they will test the application. Okay, Gaurav, Revati. I think Gaurav, I think you know here, right? So how to test all those things. I think you know this part.
So till
So
now
here the test.
you have placed the artifact in your Nexus.
Yeah.
So
Sorry?
so till now what you're saying is we have already placed artifact in my Nexus. Now next step will be going to deploy into lower environment.
Low environment, maybe testing environment or test servers. Yes. Okay.
Okay.
Yeah, I'm deploying my artifact with the application. Okay. So here
Yes.
I will configure the in Tomcat or the Nginx or Livetrace, some web server or application server. I will configure. Within that application server, I will deploy my artifact. Means application. I'm deploying my application here. So that application will test by the testers. Okay, Revati, Gaurav?
Yeah, but it's an automation testing.
Yeah, that depends upon the testing team. Okay, so manual tests, automation tests, Selenium, or performance. There are so many tools also. Okay, the testing team responsibility. They will test application.
Okay. Okay.
Okay, Gaurav?
Yeah, Ram.
Okay, here, right, so testing team find some defects, some bugs, maybe some bugs. Okay, again, so this testing team will inform to dev team. Again, what they will do, they'll fix the bugs, they'll fix it, push, or they'll integrate the code into GitHub. Again, same process. JUnit, SonarQube. So again I will Maven to.
Nexus.
So for example, yesterday one is version one. So today I will name like version 2. Okay. So again I will download and I will deploy my version 2 into low end. Again, testers will test all applications end to end using their tools and all. If everything is fine, so then only same artifact version 2 I will go to the other environment for QA, UT, some other other environment. So again here also they will test, maybe some other they will test. If everything is fine, one fine day, so they will deploy into production. Okay, any questions here, Gaurav, Revati?
No, Ram, I'm good.
Yeah, Ram.
Revati, any questions, Revati?
No, Ram. Okay.
So this part, we'll call the continuous integration. This part we'll call the continuous integration. Continuous integration. So okay, so this part, whatever, okay, with this part, so we'll call the continuous deployment. Continuous deployment. Continuous integration means, so developers, they can integrate their code into source code repository several times in a day to automate their code, to test automatically their code. So this thing will call the continuous CI. This thing, whatever we discuss, this thing will call the CD, continuous development, deployment. CI CD. Okay. CI means continuous integration. CD means continuous deployment or development, all these things. So this is the life cycle or architecture. So we can say whatever you want. Okay, any questions here?
So whatever you have done in the Jenkins part, right? You have done testing, then you have put it into Maven to build our artifact, or before that Sonar to test the code quality, right? So till this point we have not deployed any code, right? So why do we call CI? Why do we call CD this part? Continuous deployment. Till now we have not deployed anything, right?
Yes, yeah. We not deployed. Okay, you can see still here. Okay, testing. Maven we can't call the integration. Maven is the build. Maven is okay. So still here the J part we can call the continuous integration. So this GitHub and the up to JUnit part we can call the continuous the CI. Okay. So SonarQube comes under code quality. Maven build. Okay. So including this thing, okay, we can call us that CD deployment or development. Okay. So only this part or only this part also. So you can call the continuous that deployment or development. So development means, if you say development, then SonarQube and Maven will come. Development. If you say continuous development, so then Maven or SonarQube will come into picture. If you say only deployment, then only this part.
Yeah, that's what my doubt is. So CI and CD when we say, right? So CI part will come for my developer is pushing code into his branches. That is part of CD. The unit testing which he has done using JUnit, that's a CI.
Yes.
And main one is
Yeah, you continuous development CD. CD we can call development plus deployment also. If you say continuous development, then Maven also will come to picture. Maven or SonarQube also will come to picture. Okay. If you say only deployment means then only so this part.
The texting.
Deployment.
Mm.
Yeah.
okay.
Okay. So this all okay. So okay, we can configure. So we can get the pipelines. Pipelines means nothing. It's simple. Okay. Can I remove this thing?
Yeah, Ram.
Yeah, sure.
Yeah.
So here, right, as usually, so this is GitHub. So my developers, they'll push their code here. So then I have Jenkins. So here I will integrate my GitHub with Jenkins also. So once we come to this part, or from here also, okay, So here we can create the pipelines. First, my first task is job one or task one is JUnit. Once JUnit, right? JUnit. If I find any errors here, then I will configure the one notification, one email. I will give my developers or DevOps team email. So automatically the email will trigger to developers or DevOps team. So developers again they will fix the errors or bugs. Again they'll integrate. I will test. But again my job one is testing. So okay, job one is testing. Job two is triggering emails. If success also, it will trigger the mails. If fail also, it will trigger the mail. Okay, something. My job 3 is SonarQube. Job 4 is Maven. My job 6 is Nexus. Your job 7 is something, whatever you want, as per your infrastructure, as per your project requirement, whatever you want, you can create. Your job 8 is some other thing. That depends upon your project or something, okay? Our job 9 or 10 is so deploying servers into your artifact into servers. Here we can create the jobs: job 1, job 2, job 3, job 4, 5, 6, 7, 8. These are all okay, like pipeline. Once job 1 is successful, then only my so my trigger will go to the job 2. Once job 2 is successful, one job 3 is successful, one job 4 is success, then job 6. Job 6 is success, job 7. One job 7 is success, some job 8. Like pipelines, you can create it. It's all automation. With one click, so the entire jobs will execute. Okay, Revati, Gaurav.
Okay. One more doubt, Ram. So in this Git repository, the developer write the scripts. For example, 10 developers wrote the scripts. So that JUnit will testing the script. If anything, we found any defects in one, for example, D1, D2, D3, D4, all developers writing the scripts. So we can find some defect in D3. So we send an email notification to the developer. Right?
No, it will go to the entire team, not only for this thing individual. Okay, there we will give the DL name, DevOps DL or development team DL name. It will go to the entire DL, not only the individual developer.
Okay, once they fixes the defect thing, then only it will go to the SonarQube, right?
Yes, exactly.
Okay. So overall the process done, then only it goes to SonarQube. For example, we find one defect, the other will go for SonarQube. That finally we can defect the. I mean, what is my doubt is like finally we can the one defect we found in developer 3, right? So other things, everything go for the process. I mean, plug in 1, 2, 3 like that. The finally we can do this one. I mean, defect 3.
Yeah. So here, right, that depends upon your configuration. If you want to, so otherwise, right. So I will tell you. Okay. So here, as you said, so you have one branch and developer 2 branch, developer 3 branch, right? So here, right, we can create pipelines like individual branches also, like that. Okay. Okay.
Okay.
Otherwise, what I will do, and otherwise I will have the one master branch. One master branch means like main branch, master branch. I can okay. So here I can merge all my code into merge.
Okay.
I'll tell you. Okay. So
Fine.
just
We
one
can do
second. I'll
like
tell
this
you.
also. Okay. Okay.
So, so this is my GitHub. This is my GitHub. So I have the developer 1 and developer 2, developer 2 and developer 3. Okay. So here I have the one master branch, means the main branch, main repository, main branch. So okay, yeah, are you able to hear me?
Yes, sir.
Okay, right.
Yeah.
No, okay. So here, right, dev 1. So he did his coding part, and he'll push dev 2. Okay, developer 2. He did his part, and he'll push his code into his branch. Same dev 3, dev 4, dev 5, dev 6, up to something. So okay, here, right, we'll have the team lead or manager or SIP lead, right? So you see the project, right? The depends on the project. SIP lead, a team lead, a team manager. What he will do? So he will merge master branch, dev code into master branch, dev 3 code into master branch, and he will review. Before the merge, he will review. He will review D1 code, D2 code, D3 code using some tools or manually using some using the tools. So you will review D1 or D2, 3. If everything fine, so that what you will do, you will merge entire code into one master branch. Okay, so for master branch, we'll take the Jenkins.
Yeah.
Okay,
Okay.
Revati?
Yeah. Understood. Yeah.
So that is the part. So, here at the merging access only we will give to only SIP lead or TL or managed only. The individuals will not give the merging access. The D1, D2, D3 they can't merge their code into master branch without reviewing. Okay, the reviewing access, the merging access as a DevOps team, we will give only the SIP leads, or team lead, or managers, or spokes. What they will do? So they will review. Maybe they will use some tools for reviewing tools. They may internally. So they will review the code. If everything is fine, then only they will merge into master branch. Okay. Okay,
Okay.
Gaurav, any questions here?
No, Ram.
Okay, so just okay. This is that life cycle or architecture. So any questions you can ask. This recording, right, I will create one Google Drive and I will upload this recording to the Google Drive. You can download it.
Okay.
Okay,
Thank you.
the documentations I will provide. Okay, the lab we can set up in our laptop only. We can download, we can install all the tools. All the tools are open source tools. Okay, we can download, we can implement that lab, and we can practice it.
Okay.
Okay, so far any questions? Any questions so far?
No, Ram.
No, Ram. Good. I'm good.
Okay, so here, right, so okay, do you have the AWS account? AWS account do you have?
I can create one. I had one, but I disabled it long back.
Okay, disable. Okay, no problem. Just create once again with the new email ID. You
Okay.
use different email ID and you can use. Okay, so how to create that AWS account? Okay, I will give one. I will send you one video, just 5 minutes video, that YouTube video. Okay, just follow
Okay.
that video. So you can create the you can sign up your AWS account. It's free. It's free. 1 year free. So
Okay.
they, right, you have to give your credit card or debit card details. Okay, initially, so okay, they will deduct 2 rupees in Indian currency. In India, 2 rupees. In US, I don't know how much they will deduct. For only for just to check whether you are giving them that validity card or not. Just okay. After 4 days or 5 days, again they will credit your money. Whatever the 2 rupees and all, they will credit your money. So okay, it's very okay. So they will not do any in false and all. So okay. For validation purpose, we have to provide our credit card or debit card details. Okay. So for example, by chance tomorrow if you get any bill or something, 500, 200, 500, something, any bill, at least 1 rupee also, they will not deduct automatically. They will not deduct automatically. Okay. You have to pay manually. Okay, so you can trust the AWS, so no need to worry about. So open one account. So tomorrow I will tell you how to create the servers.
Okay.
Okay, right?
Yeah.
So any questions?
No, Ram, we don't
Yeah.
have.
So far so good. Yeah.
Okay, thanks. So today I will share with you this recording as well as that YouTube video, so you can create the
AWS.
AWS account.
Yeah.
Just it will take only 10 minutes. That's it.
Sure. We'll do that. Yeah.
Okay, thanks. See you tomorrow, same time, same link.
Okay. Thank you so much.
Yeah,
Yeah.
thanks.
Bye.
Bye.
Bye.